new series is starting now on decimals. Okay, so I originally made a video on kind of an introduction to decimals, but it ended up being like an hour long. I felt like that was too long, so I wanted to split it kind of into a couple of videos. So decimals, we're going to talk about adding, subtracting, multiplying, dividing, order of operations, all of that. But beforehand, we've got to kind of talk about what decimals are and how they are connected to fractions and how to convert between decimals and fractions. So that initial stuff, I'm going to do two videos. So the first video I'll do place value, writing out decimals in words, and then we'll look into converting decimals and fractions in a second video, and then we'll get into rounding and then adding, subtracting, multiplying, dividing, and order of operations. So for now, let's talk about what decimals are. So decimals are another way to represent part of a whole. All right, similar to fractions. In fact, so similar, that looks awful. Let me fix that. All fractions have a decimal equivalent. That means every single fraction can be rewritten in decimal form. Okay. Now, I do want to make it very clear that not all decimals have a fraction equivalent. Okay. So every single fraction in the whole wide world could be rewritten as a decimal, but the reverse is not necessarily true. And that comes down to number systems. There are all sorts of different types of numbers. So you've got whole numbers, natural numbers. So natural numbers would be like the counting numbers. Where do you start when you count? 1. What do you do after that? You increase by 1. So 1, 2, 3, 4, 5, 6, and so on. Whole numbers are just like the natural numbers, except you start at 0. So 0, 1, 2, 3, 4, 5. You then have integers. Integers are all of the whole numbers and then their negative counterparts. So you start, forever on the negative side, but let's say it was -3, -2, -1, 0, 1, 2, 3, but a ... on either end. And then you get what's called the rational numbers, okay? And so rational numbers technically are any number that can be written in fraction form. So any number that can be written as a fraction. And as far as the decimals are concerned, this would be decimals that terminate. So that means the decimal just ends, 0.75, 0.123, okay? Decimals that just end, nothing comes after the last number, or decimals that repeat. So decimals that would be considered rational numbers could be written as a fraction. On the flip side of that, we have what are called irrational numbers. And these are numbers that can never be written as a fraction, so cannot be written as a fraction. And these are decimals that never terminate. Or decimals that don't repeat. So your irrational numbers are going to be like the number pi, the number e, square roots that are not perfect squares, so like the square root of 2, the square root of 11, those would be your irrational numbers, okay? So for the most part, we deal with rational numbers, rational decimals at this point. When you get to the irrational stuff, you're going to see that much more when you get into radical equations, radical expressions. All right, so let's see. For now, let's talk more about these decimals. Let's talk place value. All right, now it's going to be another video that we go deep into rounding decimals, and generally you learn place value alongside rounding, but in this case we're just going to kind of talk place value, and we're going to use it to figure out how to say decimals in words, but the rounding is going to come in a future video. Okay, so in case you forgot from videos way back, place value represents the location of a digit. All right, so at the very beginning of the videos I started making, we talked about place value and rounding of whole numbers. Okay, now we're going to talk about place value of decimals. Okay, so let's pretend we have this super generic decimal here. Now, for the most part, when we're dealing with decimals in math, you won't see that many decimal places. And just so you know, decimal places, I'm going to use that word a lot in this series of video. Decimal places means the number of digits after the decimal point. So this particular number has 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. And for the most part, you're not in this class going to be dealing with decimals that have 9 decimal places. Okay, you'll generally see numbers that have 3 and 4 decimal places, sometimes more. All right, but just know decimal places. Now, what I'm going to do is I'm going to look at each digit here, the 1, the 2, all the way through the 9, and I'm going to tell you its location in that number. And while I do that, I'm also going to show you kind of how this relates to fractions. Okay, so let's start with the 1. The 1 is what we call the tenths place. And when you see the word tenths, you should think 1 over 10. And what I want you to notice is we're 1 decimal place in, and 10 or tenths has 1 0. So think powers of 10 here and the number of zeros they have, and you're going to see a connection between the number of zeros and the powers of 10 that kind of coincide with these place values. And then you'll also notice that it represents the same number of decimal places. So it's a little weird sounding until you see the pattern, but let's just go ahead and keep going. The 2, which is in that second spot, it's 2 place values in, or 2 decimal places in rather, that would be the hundredths place. And notice I'm kind of being really dramatic with that the THS at the end. After the decimal point, you have to have that THS. Now, if you're in the hundredths place, that coincides with 1 over 100. And notice how many zeros are in 100? 2. How many decimal places in are we? 2. Okay, looking at the 3, we have the thousandths place. Again, get that THS in there. The thousandths place, and that does coincide with 1 over 1,000. And notice, how many zeros are in 1,000? 3. How many decimal places in are we? 3. Now, what do you think the 4 would be? What power of 10 has 4 zeros? Well, 10,000. So this would be the 10,000ths place. And that does coincide with the fraction 1 over 10,000. 4 zeros, 4 decimal places in. Now, what about the 5? You would ask yourself, what power of 10 has 5 zeros? Well, 100,000 has 5 zeros. So this is the 100,000ths place. That looks kind of messy, 100,000ths place. And that does coincide with 1 over 100,000. And just to make it really clear, 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5 decimal places in. Let's move on to the 6. Now, what power of 10 has 6 zeros? Hopefully you'll remember that 6 zeros are in a million. So this is the millionths place. And it does coincide with 1 over a million. All right. So 6 zeros here, 6 decimal places in. Now, 7 is 7 decimal places in. The power of 10 that has 7 decimal places, or 7 zeros rather, would be the 10 million. So this is the 10 millionth place. So it does coincide with 1 over 10 million. Notice I've got 7 zeros and I'm 7 decimal places in. 8 would be 100 millionth place. Because 100 million has 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then finally, the 9 would be in the billionths place. And this does coincide with a billionth. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros, 9 decimal places in. So when you're dealing with decimals, powers of 10 coincide with decimal places. So if you're 5 decimal places in, you're going to be in that power of 10 that has 5 zeros, but just always make sure you think of it kind of in fraction form. You got to get those THSs in there. Those THSs make these fractions happen. So it's not the millions place, it's the millionth place, like 1 millionth. Okay, so there's your powers of 10. All right, next up, what we need to do is learn how to say decimals in words. Okay, so let's say that I had the decimals to words, and let's say I had the decimal 0.84. Now 0.84, if I say 0.84, we know what I'm talking about, but that's not the proper way to say this decimal. So here's the proper way to say it. If you have something in front of the decimal, you say that as if it's a whole number. When you get to the actual decimal point, you say and then when you get to the stuff after the decimal, you say it as if it was a whole number. So for us, 84 is just the number 84. And then you always look at the very last digit and you state the place value of the last digit. So say or write the number before the decimal point. All right. Say or write and in place of the decimal point. Okay. And then you want to say or write the number after the decimal point. And you want to say it as if it were a whole number. And then end with the place value of the last digit. Okay. So we have nothing in front of the decimal point, so we can skip steps 1 and 2 here. We don't have to say 0 and, okay, you don't have to say that when there's nothing in front of the decimal but a 0, but we do want to say this 84. So remember, we decided 84 is just 84. And then you want to look at the last digit. Well, the last digit is 2 decimal places in. 2 decimal places coincides with a power of 10 that has 2 zeros, so 100. So this would be 84 hundredths. And that's it. All right. Let's try this one. 5.2. Again, I can say 5.2 and you know what I'm saying. If you say 5.2, I know what you're saying, but we need to learn the formal, proper way to say these numbers. So we start by saying the number before the decimal point, 5. So we're going to write out 5. When you get to the decimal point, you say and. So 5 and. Then you say the number after the decimal point as if it was a whole number. We just have a 2, so we're going to say 5 and 2. And then you look at the place value of the last digit. Well, the last digit is 1 decimal place in. One decimal place coincides with the power of 10 with 1 0, so 10. So this is just 5 2/10. All right. What about 2.014? Okay. Well, we say the number in front of the decimal. So we say or write 2. When we get to the decimal point, we say or write and then anything after the decimal, you say it as if it was a whole number. So 014, we would just say is 14 or 14. And then the last digit is 3 decimal places in. 3 decimal places coincides with the power of 10 with 3 zeros, so that would be 1,000. So this is 2 14 thousandths. All right. Let's do, I think we can fit a couple more on here. So what if I have 23.0033? Okay. So we start by saying the 2 digits before the decimal point. That's just 23. All right. You get to the decimal point, you say and. And then you say the digits after the decimal point as if they were a whole number. Well, 0033, we would just call 33 or 33. And then the place value of the very last digit, well, the last digit is 4 decimal places in. The power of 10 that has 4 zeros is 10,000. So this would be 23 33 10,000ths. And that's all she wrote. Okay. One more. Now that you're dealing officially with decimals, you're going to see a lot more with money. Now, you can definitely see money when you're dealing with whole numbers, but when you start to work with decimals, you see it more. Okay. So a couple of things I want to tell you now about money. Money for us always has 2 decimal places. So if you're working with money and you say you're dividing or multiplying or something and you get more than 2 decimal places, that would require rounding. You always want to round so that you have 2 digits after the decimal point. Now, anything in front of the decimal, we call it dollars. Anything after the decimal, we call it cents. Most of us already know this, okay? So this would just be, well, 857 is 857. You don't really say this the same way you do regular decimals, because we're going to say $857 and then you say the digits after the decimal point, 83, but you don't want to end with place value. You want to end with cents. All right. And again, most of us already know how to deal with money because we use it every day. So we know how to say $857.83, but just make sure you got it clear in your head. And now that we're in decimals, you're going to see money a lot more. Okay. Now let's do the opposite. So we'll go and write in decimal notation. So for this section, we're going to have a number written out in words, and we want to convert it back to decimal notation. So just like numbers with a decimal point. So what if I have 8/10? Well, I look for the place value, in this case, tenth, okay? Now there's no and, there's nothing like before a decimal point and, so this is going to just be 0.0 something. Look for the decimal, or look for the place value for the decimal, so tenths. Well, we know 10 has 1 0, so we have 1 decimal place, and this number goes in that decimal place. That's it, 8/10. What if I had 45 hundredths? Okay, well, there's no like number and, so this is another situation where you just have a decimal. You don't have like the whole number part. You have nothing in front of a decimal point. So we would just start with 0 and a decimal, and then look for the place value. The place value here is the hundredths. Well, how many zeros are in 100? 2. So that means we're going to have 2 decimal places. And this stuff right here is going to fill in those decimal places. So this is 45 hundredths. Let's say we have 958 10,000ths. So again, just like the first two examples, we don't have the word and, so we don't have a number before the decimal point. So you can start with 0 point and then look at the power, or look at the place value and consider it as a power of 10. So we're in the 10,000ths place. How many zeros are in the power of 10, 10,000? Well, 4. All right. And this right here, 958, is going to fill in those decimal points. But remember, if we go back a slide, when we're saying numbers out or writing out numbers, you always end with the place value of the last digit, okay? So when we see this 10,000ths, that is the last digit. So 958 has to go all the way at the end here. And what do you think I put in this first spot between the decimal point and the 9? Well, just a 0. Okay, so always remember the place value indicates the location of the very last digit. So 958, the last digit's 8. 8 has to be in the 10,000th place. Okay. One more. For this one, I have 23 and 6,211 millionths. Whoops. Okay, so a couple things. I do have a number, the word and then another number. Okay, I didn't mean to cross that out. I meant to underline it. So I do have digits before the decimal point. So I'm going to write out 23. So just 2, 3, and then a decimal. Okay. Now I want to make note of the place value. Now remember, this is the place value of the last digit, and it's in the millionths place. Now keep in mind, a million has 6 zeros, so that's going to be 6 decimal places out. Okay. So now I look at 6,211. That would be 6211. Well, the last one has to be in the millionths place. So that's 6,211. So in front of the 6 and after the decimal point, I have to fill in zeros. This now says 23 and 6,211 millionths. Not bad? Okay. Now, last up for this video, we're going to write decimals as reduced fractions or mixed numbers. Okay, so what I'm going to do for this video is I'm going to end it with writing decimals as fractions or mixed numbers. The next video, we're going to talk about rounding, we're going to talk about comparing, and we're going to talk about ordering, and then we're going to talk about converting fractions to decimals. And I might do that in reverse. I might decide that the second video is going to be converting fractions to decimals and then do the comparing. But either way, this will be the end of this video, and then 2 more are going to come after this before we get to adding and subtracting, multiplying and dividing decimals. Okay, so decimals as reduced fractions or mixed numbers. So let's say I have the decimal 0.88. Okay, a couple of times in this video already, we've seen the connection between decimal places, that's the number of digits after the decimal point, and powers of 10 and place value. So it all kind of comes together. So when I see a number like this and it's 2 decimal places in, I know this coincides with the power of 10 that has 2 zeros. So what I want to do is go ahead and write this, and I'm going to start my fraction, and my denominator is going to have to be the power of 10 that has 2 zeros, hundredths. Because remember, 2 decimal places in, we're in the hundredths place. And then all I do is put my numerator as the actual decimal. Okay. But now I would have to reduce. Okay. And reducing can be a little difficult. And when I'm in a regular classroom, this is the point where I start letting you use your calculator a little bit more. Okay. So you could reduce your fraction on the calculator. And if you know how, I get it. Go ahead, do it. We've already proven that you can reduce fractions in the previous series of videos. But for those of us that are going to still do this by hand, we notice that 88 and 100 are both even. So that means they're both divisible by 2. 88 divided by 2 is 44. 100 divided by 2 is 50. So I've now got 44 50ths, but 44 and 50 are still even. So 44 divided by 2 is 22. 50 divided by 2 is 25. Now I'm reduced. So the decimal 88 hundredths is really the same as the fraction 22 25ths. Not bad, kind of fun. Let's try another one. Let's say I have 2.8. Now, one thing I want you to know is if you have a decimal with nothing before the decimal point, that would basically correspond with a proper fraction. If you have a situation where you have a number before the decimal point, that corresponds to a mixed number or an improper fraction. So in this case, we're going to write it as a mixed number. So I'm going to go ahead and start with 2, and then I'm going to look at the decimal point, and I'm going to make it the fraction. So I've got one decimal place here, so that's going to correspond with a fraction where 10 is the denominator, and then I just put the numerator as whatever my decimal is, so 8. So 2.8 so far corresponds to 2 8/10, but I do want to reduce it. 8 and 10 are both divisible by 2. So I get 2 4/5. Piece of cake. What if I have 6.073? Again, I'm going to have a mixed number because I have that number in front of the decimal. So this is going to be 6 and some fraction. Well, if I look here at 0.073, I've got 3 decimal places. That corresponds to the power of 10 with 3 zeros, so 1,000. And then this decimal just becomes my numerator. So this is 6 73 thousandths, and that is reduced already. What about 18.675? So again, a mixed number. All right. So I get 18, and then I'm going to get some fraction. Well, I've got 3 decimal places, so my denominator needs to be a power of 10 with 3 zeros. Okay. I put the 675 in the numerator, and then you just start dividing. And really, if you do this by hand, I encourage it, honestly, because you need to kind of get these skills kind of going back to the forefront of your brain. You need to start doing this stuff by hand. You need to start recalling how to do these calculations. Sure, your calculator can be there to help you, okay? But something like 675 over 1,000, it seems like it would be impossible to reduce. But 675 ends in a 5, 1,000 ends in 0, so you at least know that these are divisible by 5. So what I would encourage you to do, instead of just doing this all on the calculator, use the calculator to help you with the calculations, but still reduce by hand, if that makes sense. So we know these are both divisible by 5, so maybe do the 675 divided by 5 on your calculator, and we get 135. 1,000 divided by 5 is going to be 200. So even though you're using a calculator to assist you, still do some of it by hand so that you can always remember. You can get that practice in on how to reduce fractions, okay? So let's see, 135 and 200 end in zeros and 5s, so they're both divisible by 5. 135 divided by 5 is going to be 27. 200 divided by 5 is 40. Now, 27 has factors of 27, 3, and 9. None of those go into 40. So at this point, you are reduced. So 18.675, or 18 675 thousandths, is equivalent to 18 27/40. Okay? So there you have it. It's pretty easy to take a decimal and to write it as a fraction or a mixed number. All right, kind of fun. Let's do maybe one more just to make sure we're totally good. What if I have 0.0188? Well, there's nothing in front of the decimal, so this is just going to be a proper fraction. My denominator is going to be the power of 10 with 4 zeros, so 1,000. All right, 4 decimal places out corresponds to 1,000, so I'm in the thousandths place. And then I just put my numerator as 188, and then we reduce. All right, so again, you don't necessarily need to always jump straight to your calculator. It certainly saves you a few seconds, okay? But if you don't practice reducing fractions, it's never going to stick with you. And then in a few years, you're going to find yourself right back where you are now. So let's try to do this by hand with the assistance of a calculator. So let's say that you recognize that 188 and 1,000 are both even. So you're like, okay, they're at least divisible by 2. So 188 divided by 2 is 94. 1,000 divided by 2 is 500. So we clean it up a little bit and we now have 94 over 500. But 94 and 500 are both even again. So 94 divided by 2 is, let's see, 47. 500 divided by 2 is 250. So I get 47 over 250. And 47 has no common factors with 250, so we are done. All right. So even though we still reduced by hand with the assistance of a calculator, it was still pretty quick. All right. So I would definitely encourage you to practice reducing your fractions. Okay. If you completely skip this process, you're never going to like learn it thoroughly. And it's just going to kind of always be a problem. Okay. So practice this stuff. Use your calculator as an assistant, but not as like the main tool. Okay. Now, I've decided kind of in this last second that I do want to go ahead and show you how to do some conversions of fractions to decimals. Okay, but we're going to do the easy stuff. So fractions to decimals, but here's the condition. Denominators are powers of 10. In a later video, I'll show you how to convert all fractions to decimals, regardless of what their denominator is, okay? So in this case, let's say we start with the fraction 9 over 10. Well, if I go back a slide, let's see. I noticed that like if I have 2.8, that 0.8 corresponds initially to 8/10, right? Well, the same thing happens here. Whoops, I got one more slide, right? So I know this power of 10 in the denominator, I count the zeros and the zeros are going to tell me how many decimal places I have in my decimal. Well, 10 has 1 0. That means this is going to coincide with a decimal with 1 decimal place. And I know this is going to be a decimal where there's nothing in front of the decimal point because this is a proper fraction. Okay, so 10 is the denominator. 1 0, 1 decimal place. I'm in the 10th place, which is 1 decimal place out. All I do is take my numerator and fill it in, and that's it. Let's try some more. What about 54 over 100? Well, this would be called 54 hundredths. So the hundredths place is 2 decimal places in. Again, I have a proper fraction, so I know there's nothing in front of the decimal. And now I just take my numerator and fill it into those decimal places, and that's it. What if I had something a little different and I had 7 hundredths? Well, 2 zeros means 2 decimal places. Again, it's a proper fraction, so we know we're going to have no number other than 0 in front of the decimal point. Now I need to fill in my numerator. The issue is the place value corresponds to the last digit in the number. So if this is 7 hundredths, 7 is going to be in that last spot. So what do you think I put here between the decimal point and the 7? Well, I would just put a 0. So this is now 7 hundredths. Make sure you don't put the 7 here. If you did that, that would be 7/10. What about 62 over 1,000? Well, it's a proper fraction, so I can start with 0 and then a decimal. 1,000 has 3 zeros, so that means I'm 3 decimal places in. That's the thousandths place right here. And this 2 is in the thousandths place. Remember, the last digit always corresponds to the the place value that we're talking about. So I would put my numerator here, and then anything between the decimal point and the rest of the number just gets filled in with zeros. So this is now 62 thousandths. What about 3,620 hundred thousandths? Well, we're dealing with a proper fraction, so we can start with 0 point, and then I've got 1, 2, 3, 4, 5. All right. So I've got 1, 2, 3, 4, 5, and this one's going to be a little weird. I'm going to show you something in just a second. So this right here is going to get filled in at the end of my decimal places here. Okay. So I get 0.03620, but here's something weird that happens with decimals. You don't need this last digit if it's a 0. Okay. So if your last digit ends up being a 0, you kind of chop it off. And so I get 0.0362, but now we don't have 5 decimal places. Well, no big deal, because look at what happens. I get 362 over 10,000, right? No big deal. But if I look at this, you're like, it doesn't look the same. Well, that's okay, because if numbers end in 0, they're both divisible by 10. So if I were to take this right here and reduce it, 3,620 divided by 10 is 362. 100,000 divided by 10 is 10,000. So this right here is kind of a little bit trippy, but if a decimal ends in 0, it's kind of the equivalent of a fraction not being reduced. So you can chop that 0 off at the end, and it kind of reduces the decimal. It makes it into a reduced fraction to some degree. Now, of course, this is not fully reduced. We know that 362 and 10,000 are at least even, so they're at least both divisible by 2, but we're just saying this definitely was not reduced. So we reduced it down at least a little bit. Okay, so kind of remember this situation here, and we'll talk about this a bit more later, but I wanted to at least bring it up now. Okay, let's see. Do I have any other examples? What about this one? How would I write 18 and 4/10 as a decimal? Well, I've got a mixed number, so the whole number is going to be what goes in front of the decimal. And then for the decimal, this fraction 4/10 is going to be my decimal. Well, 10 has 1 decimal place. So, or it has 1 0, which corresponds to 1 decimal place. So I just get 18.4. What about 55 and 93 thousandths? Well, it's a mixed number. So the whole number is going to be what goes in front of the decimal, and then the fraction is going to be converted to a decimal after the decimal point. 1,000 has 3 zeros, so I'm going to have 3 decimal places, and this numerator goes at the end. So I get 55 and 93 thousandths, or 55.093. What if I had 7 millionths? Well, this is a proper fraction, so I can start with 0 and a decimal. I count my zeros, 1, 2, 3, 4, 5, 6. So 7 millionths is going to have 6 decimal places. And the numerator is going to go all the way at the end. You want to make sure the last digit of the numerator is in the last decimal place. And then you fill zeros in before that. And that's it. So at this point, we know what decimals are. It's a way to represent part of a whole, similar to fractions. We have a huge connection between decimals and fractions, so much so that all fractions have a decimal equivalent, but the reverse is not true. There are some decimals that don't have fraction equivalents. We have basically 2 types of decimals, or 2 types of numbers. We have rational numbers. Those are any numbers that can be written as a fraction. So those would be the decimals that terminate. That just means the decimal ends, or decimals that repeat, like 0.33333 forever. We then have irrational numbers, which are numbers that can never be written as fractions. All right, so these are decimals that never terminate. That means that decimal never ends, and they never repeat. Okay. We talked about place value. So I just gave you this generic decimal 0.123456789, and we looked at the place value of each digit in that number. And what we noticed is the name of the place value corresponds to a power of 10 that has the same number of zeros as that decimal place. So the 1 is 1 decimal place in, it corresponds to 1/10. So it's the tenths place. Then we have the hundredths place, thousandths place, 10,000ths place, 100,000ths place, millionths place, 10 millionths place, 100 millionths place, billionths place. And notice the fraction equivalents. Notice specifically the zeros in the power of 10 and the number of decimal places for that place value. All right. We then talked about how to write decimals as words. We talked about how to take words and write them as decimals. So let's see, did I get, this is the one I want. So we took numbers written out in words and we converted them to decimal notation. All right. We wrote decimals as reduced fractions or mixed numbers. And then finally, I did show you how to convert fractions to decimals, but very specifically fractions where the denominators were powers of 10. All right. So for the next video, I'm still on the fence about which video I'm going to do next. 2 videos are coming. One of those videos is going to talk about rounding decimals. We're going to talk about how to order decimals. We're going to talk about comparing 2 decimals, like which decimal is bigger. And then the other video is going to talk about converting all fractions to their decimal format. So the denominator doesn't have to be a power of 10. Okay. And then at some point in those 2 videos, I'm also going to show you how to compare a decimal to a fraction and how to put a group of those in order. So I'm not sure exactly how I'm going to split those 2 videos up, but those 2 videos will be split up so that neither of them is like too long. And then after we get through the next 2 videos, then we're going to do adding and subtracting together because they're similar, and that's really, really easy. Then we'll talk about multiplying decimals. Then we'll talk about dividing decimals. We'll do estimation of decimals, and then we'll do order of operations. So this series of videos is going to be several videos long, but not quite as long as the fraction series. All right, best of luck.